Welcome back, AI developers. Today, we are moving beyond simple linear pipelines and entering the dynamic world of the graph paradigm. We will master nodes, edges, and state to build highly autonomous, stateful AI agents. Let's get started. Let's kick things off by defining the graph paradigm. Historically, AI workflows were linear, step A to step B to step C. While useful, these linear-directed acyclic graphs, or DGs, have strict limitations when trying to create truly dynamic AI agents. They lack the ability to easily loop back on themselves to correct mistakes. The graph paradigm models agent workflows as graphs. By introducing cycles, our agents can perform iterative processes, pause for feedback, and loop recursively. This is the foundation of genuine agentic intelligence, and it is achieved by coordinating three essential components: state, nodes, and edges. Take a look at this flowchart. On a standard linear chain, data moves left to right and stops. But in the graph paradigm, notice the loop. The LLM reasoning node evaluates the query. The edge asks if a tool is needed. If yes, it routes to the execute tool node, which loops right back to the LLM. This cycle continues until the task is complete, unlocking autonomous behavior. To build an intelligent agent, it must be able to remember its past actions. This brings us to the first pillar of the paradigm, the state. The state represents the current snapshot of your application. Because large language models are inherently stateless, we must pass them a persistent memory object. In practice, the state is defined as a Python-type dict or pydantic base model. It acts as the single source of truth. As your agent runs, the state flows through the graph. Crucially, the state includes reducer functions. When an agent generates a new message, the reducer ensures this message is appended to the ongoing chat history, rather than overwriting it, maintaining perfect continuity. This diagram illustrates the centralized nature of the state. The yellow central graph state holds the schema, like our messages and status. Node 1 performs its work and emits an update back to the state. Then, Node 2 draws its context directly from that freshly updated state before emitting its own updates. The state is the heartbeat connecting isolated functions. If the state is the memory, the nodes are the muscles. Nodes are standard Python functions that encode the actual logic and behavior of your agents. A node can be anything from a simple string parser to a complex call to an LLM or the execution of a Python script. The contract for a node is simple. It takes the current state as its input, does some computational work, and returns a dictionary representing the updates to that state. When you build your graph, you inject these functions using the addNode method. We also utilize special virtual nodes, explicitly named start and end, which define the absolute entry and terminal points for the data flowing through your application. Let's trace the anatomy of a node execution. The current state flows into the node function on the left. The function reads the necessary variables, executes its internal LLM or tool logic, computes the result, and generates a state update. This update merges into the global state, creating the updated state payload ready for the next step in the graph. We have memory and we have workers. Now we need a manager to direct traffic. This is the role of edges. Edges determine the next node to execute based on the current state. They guide the flow of operations. You can use normal edges for fixed transitions, meaning node A will always go to node B. However, the true magic lies in conditional edges. A conditional edge uses a custom Python function to examine the state and decide where to go next dynamically. For instance, it can check if the LLM outputted an error. If yes, it routes to a correction node. If no, it routes to the end node. This dynamic routing is what transforms a static script into an intelligent, decision-making agent. In this control flow diagram, the LLM evaluator finishes its task and passes control via a normal edge to the router function, represented by the yellow diamond. This is our conditional edge logic. Based on the state, it makes a three-way dynamic choice, routing to the end node for success, triggering the execute tool node, or escalating to a fallback agent if an error occurred. Let's deep dive into the code implementation using LangGraph. We bring state, nodes, and edges together using the stateGraph class. First, you initialize your builder by passing your state schema. Then, use builder.addNode to register your Python functions as named nodes. Next, you wire them up using builder.addEdge for strict paths and builder.addConditionalEdges for dynamic routing. Finally, you must call the .compile method. This is crucial. Compiling performs structural checks on your graph, ensuring there are no orphaned or unreachable nodes, and it attaches runtime arguments like memory checkpointers. Once compiled, your graph is a fully executable, stateful AI application. This class diagram outlines the architecture of the state graph object. You can see the public methods we just discussed: add node, add edge, and add conditional edges. Once all components are registered, calling the compile method transforms the blueprint into a compiled graph object, which exposes the invoke and stream methods we use to actually run the agent at runtime. Let's apply this paradigm to a real-time, highly valuable use case: intelligent support triage. Imagine an enterprise flooded with support tickets. We define our graph state to hold the ticket string and an empty category field. The start edge feeds the ticket to our first node, the categorizer LLM. This node's only job is to analyze the text and update the state's category field to either billing or technical. Next, a conditional edge reads that updated state. If it sees billing, it dynamically routes the graph to a specialized billing node equipped with database tools. If it sees technical, it routes to an IT node equipped with log search tools. This architectural pattern guarantees deterministic, reliable orchestration over the non-deterministic reasoning of the LLMs. Follow the ticket through this flowchart. It originates at start, gets processed by the categorizer node, and hits the purple conditional edge. Based on the state update, the traffic cleanly splits to either the billing agent or the tech agent. Both specialized paths eventually converge back using normal edges to a single summarize resolution node before safely exiting the application at Yendi. As we conclude our deep dive into the graph paradigm, let's lock in some best practices. First, keep your node functions pure. They should only read from the input state and return state updates. Avoid modifying external variables directly to prevent side effects. Second, rigorously type your state schemas using Pydantic to ensure predictable data payloads. Finally, be very deliberate with your state reducers. Use tools like add messages to ensure your LLM's conversation history grows safely without being accidentally overwritten. Mastering nodes, edges, and state elevates your AI engineering from simple prompt scripts to robust, enterprise-grade software. I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Keep building the future. This final mind map summarizes our entire architectural journey. Graph paradigm mastery requires balancing our three core pillars. State requires typed schemas and reducers. Nodes require pure logic interfacing with LLMs and tools. Edges govern the system through normal and conditional routing. Combine these effectively, and your agentic systems will be practically unstoppable.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.